Hello, everybody. Welcome to my tutorial on performing an independent samples t-test using the IBM SPSS interface. My name is Jesse, and today I will walk you through everything you will need to know to run a statistical test step by step using the built-in bank loan dataset that comes with the SPSS interface. Now, if you're new to SPSS or statistical testing, don't worry. I'm going to explain every part of the process clearly, from opening the dataset to selecting the right variables, running the test, and finally interpreting what the results mean. So we'll first get started by answering the question of what exactly is an independent samples t-test. Well, simply put, it is a statistical method used to compare the average value of a continuous variable between two independent groups. Now, I know that was a mouthful, so we will do our best to break that down. A continuous variable is any measurement that can take on a wide range of values. So it's not per se just limited to categories or labels. For examples, things like height, weight, income, or even in our case for this video, debt to income ratio. These values can vary smoothly and aren't simply just a yes or no answer. Next is the two independent groups. That means that the groups that we are comparing don't actually overlap. They are separate from one another. In this data set, our groups are the people who either defaulted on their loans and the people who did not. So each person belongs to either one group, either defaulted or did not default. The independent samples t-test lets us check if the average debt to income ratio for those who defaulted is significantly different from the average debt to income for those who did not default. Now, this is important because it helps us understand if the debt to income ratio could be a factor related to loan defaults, which could be useful in making decisions in finance, banking, or lending. This test will help us understand if there's actually any significant difference between these two groups. Now, over the course of this video, we'll also get you familiar with the SPSS interface, learn how to handle the dataset, and develop an understanding of how to interpret the output that SPSS generates. And by the end of the video, you should feel more confident running this test on your own datasets and explaining what the results could mean. Now, if you want to follow along with this video, make sure you already have the IBM SPSS interface installed and the bank loan dataset ready. That, this bank loan dataset usually comes preloaded with the SPSS interface, but just in case it doesn't, I'll make sure I go through the steps and showing you how you can locate it. So first, we'll get started by jumping right on in. Since I am currently on my desktop, I will start off by sharing my screen and getting the SPSS interface loaded. So bear with me as we start doing that. So we got everything pulled up here and are now on the desktop. So give me just a second. But first, get started by getting the IBM SPSS statistics program loaded. Right. Now, just depending on your PC, it could take either more or less time to load. I am currently using the free trial for the sake of this video, but if you are wanting to take this to the next level, IBM does provide sales and different deals in regards of purchasing a license. Additionally, if you are a student, you may be able to check in with your university to see if there are any savings or deals that you may be able to obtain. So now that we actually have got the IBM SPSS interface loaded, we're going to first start off by selecting the new data set. There we go. Should take a second for that to load. Perfect. Okay. So now once SPSS opens, you will see the welcome screen, or in this case, the data editor window, which looks like a spreadsheet. This is called the data view, hence right here. Now here rows represent individual cases or observations, and columns represents variables. Now we're going to need to open our data set. To do that, I'll first start off by clicking on the File menu, the top left-hand corner. Excuse me. We'll go hover over to Open, and then finally select Data. Now, for the sake of this video, it looks like that the data set is already pretty much, the path for it is already pretty much preloaded for me. But in case you need to find it on your own PC, I'll kind of go through the steps of locating it through your C drive, your program folder, and so on from there. Starting off in the C drive, going to Program Files, IBM, SPSS Statistics, going over to Samples, choose the language of your choosing, in this case English, and finally, the bankloan.sav. Perfect. Okay. So scrolling through the columns here, you can see various variables related to the bank loan data. Let's see here. So different things such as age, education, employment, address, income, debt to income, credit debt, other debt, default, and then pre-definitions. Now, to get a better understanding of these variables, what we'll do today is actually switch to the variables view here at the bottom left of the screen. So here, each row represents one variable, and you can see details like the variable name, type, width, decimals, labels, and values. For example, the variable default, let me see where that is, right here, is coded numerically, where 0 means the client didn't make a default on their loan and 1 means that they did. Just in case you would like to make sure that that information is correct, you can right click, or in my case, since I'm using a laptop, double tap and go right down to variable information. And here you can see that the actual values are set to 0 and 1, just as we mentioned, for 0 meaning no, and 1 meaning yes, that they did default. Now, this variable, this variable view helps us confirm the types and the coding of variables for running any analysis. Now that we've loaded our data and have gotten a bit familiar with SPSS, let's start getting a better understanding of the statistical test that we're going to run, the independent samples t-test. This test is one of the most commonly used tests in statistics when you want to compare the average values of a continuous variable between two separate groups. Don't worry, we'll break that down a bit further so it's a little bit easier to understand. To break that down, the independent samples mean the two groups that we are comparing are unrelated or distinct, meaning that there are no overlaps or no repeating measures. For example, imagine a bank wants to compare the average debt to income ratio between two groups of customers, those who have either defaulted on their loans and those who have not. Since each customer only belongs to one of those groups, the groups themselves are independent. This is different from let's say, a paired samples t-test, where you compare measurements taken from same individuals at two differing times. like for instance, their test scores before and after a training program. The other key part is the t-test itself, which is the statistical procedure that determines if the difference between the group means is likely to be real, that is statistically significant, or if it could have happened just by chance. Statistical significance is usually assessed by something called a p-value, whereas if that p-value is less than 0.05, it is commonly accepted as a strong evidence that the group really do differ. So in our case, the continuous variables we are comparing is the debt to income ratio, which is the number representing the proportion of a person's debt relative to their income. The two groups are people who have defaulted on their loans and those who have not. The independent samples t-test will help us answer the question, is the average debt to income ratio significantly different between these two groups? Now, it is important to note that this test relies on several different assumptions, including that the observations are independent, the variable is approximately normal distributed within each of the groups, and that the groups have roughly equal variances. Now, luckily, this SPSS interface will help us check these assumptions and will even adjust the test if some of the assumptions aren't perfectly met. Now, overall, the independent samples t-test is a powerful tool to compare groups and draw meaningful conclusions based on the data. Now, before we run the independent samples t-test, it is important to prepare and understand the variables we'll be using in our analysis. First, we'll need to confirm that the grouping variable, in this case, default, is properly coded. In the bank loan dataset, the default variable indicates whether a customer has defaulted on their loan. It is a category variable within two groups, just kind of like what we mentioned. 0 means that the customer did not default, and 1 means that the customer did default. To check this was done using the variable's information and confirming that they are properly set. Now, it is really important to note, by default, SPSS will assume that the grouping variables uses the values of 1 and 2 to distinguish between your groups. So if your data set is using 0 and 1 instead, just like here in this the bankloan.sav data set that we're working with, it is important to make sure that your analysis is matching that as well. So let's see here. We'll go ahead and close this window. Yeah, so if you don't manually verify and set the correct group variables, SPSS may not recognize the groups properly during your analysis, or even worse, it could exclude cases or produce misleading results. This is why it is important to always review your data before running any kind of statistical test. Your grouping definitions need to align exactly with how your data is structured. Once the grouping variable is correctly labeled, we turn our attention to the test variable. The continuous variable will be comparing across groups. In our case, this is the debt to income, or the customer's debt to income ratio. So what we'll do is come over here and view that it is not missing any values, and the fact that it is also numeric. Here, what we'll also notice is that we didn't have any specific value labels. Now, this is to be expected since the debt to income is a continuous measurement and is not specifically set as a category, such as the debt, which is either, I'm sorry, not debt, but default, whether you defaulted or you did not. Now, with both variables confirmed and prepared, the grouping variable is labeled correctly, and the continuous variable is properly formatted, we are now ready to move forward to run the actual independent samples t-test. Let's see here. So now that we've properly defined our grouping variable, in this case, whether a customer has previously defaulted on their loan, coded 0 for no and 1 for yes, we've selected our test variables, the customer debt to income ratio, we're ready to run the independent samples t-test. Let's see here. So to run the test, excuse me, I just realized I repeated that exact same thing. We'll go over here to analyze, hover over where it says compare means and proportions, and then finally select the independent samples t-test. Now, in this specific dialog box, we'll start by moving our test variable, which we have defined as debt to income, into the test variable field. Then I will select our grouping variable, which was default, and move that into the grouping variable field. So first thing we'll do is grab that debt to income. It's right here. Move that into the test. Here's the default. Move that into the group. Now, what we were mentioning before, this is where it becomes very important to make sure that you define those groups important. Excuse me. And that can be done right here, where we mentioned group 1 is set to the value of 0. And group 2 is set to the value of 1. And then we will select continue. And then finally, we will select OK to run the test. Make that larger. Okay. So SPSS is going to generate several different tables for us. So what we will do first is let's start with the group statistics table, all right here. So this shows us the mean, the standard deviation, and standard error of the debt to income ratio for both groups. For customers who have not defaulted, the average debt to income ratio is around 8.67, found here. For customers who have not defaulted, the average is significantly higher, around 14.72, which is indicated there. Now, already we can see that there is a noticeable gap, but we need statistical evidence to confirm that this difference is not just due to random chance. That's where the next table that we work with comes in, which is the independent samples t-test. So next, we will review this independent samples t-test table, which is the heart of our analysis. The independent samples t-test basically has two different roles. One, which assumes equal variances between the groups, and the other that does not. To know which one of these rows to use, we normally check the Levine's test for equality of variances. In this case, it's suppressed in our output, so we'll focus on the equal variances not assumed row. This one down here. This is usually going to be a safer option when you are ever in doubt. So now we're going to start working on interpreting this data. The T statistics, which is this number found down here, is at negative 9.537, which tells us how far apart the two group means are in standard error units. The degree of freedom are about 250, which SPSS adjusts when variances are not assumed to be equal. The two-sided p-value is less than 0.001, which is well below the common significant threshold that we mentioned earlier of 0.05. So what this tells us is that the difference in average debt to income ratios between the defaulters and non-defaulters is statistically significant. In plain terms, people who defaulted on loans tend to have a higher debt to income ratio, and that is very unlikely to be pure coincidence. Next, we will start reviewing the independent sample effect sizes. So the Cohen's d is at 0. I'm sorry. Back up here. Yeah, so the Cohen's d, which is found right here, is at a negative 0.961, which is found right here, the point estimate, which falls in the large effect size category. Hedges correction, which adjusts the Cohen's d for small sample sizes, almost nearly the same, right underneath here. Lastly, the glass delta uses only the control group standard deviation, and it gives us a negative 0.765. So these values, particularly the Cohen's d, confirms that the gap to debt, I'm sorry, I said that kind of strange. In these valuables, particularly the Cohen's d, confirmed that the gap in the debt to income ratios between the defaulters and non-defaulters isn't just statistically significant, it's practically meaningful. This could have real-world implications for how banks assess loan risk and determine lending thresholds. Now that we've ran this test, we need to interpret our results within the context of our hypothesis. In this analysis, we were testing whether the debt to income ratio plays a significant role in whether or not a person's defaults on a loan. Our null hypothesis in this case was that the debt to income ratio has no significant impact on defaulting. In other words, that people who default and those who don't have an average similar debt to income ratio. Now, the alternative hypothesis that we were testing against is it's the opposite. The debt to income ratio does, in fact, make a difference in that those who default may have significantly different ratios in comparison to those who did not. Finally, to start wrapping everything up, the independent samples t-test shows us that there is a real difference between people who defaulted on loans and those who did not, specifically in their debt to income ratios. And this difference isn't just some minor variation. Statistically, it is a significant and meaningful gap. On average, people who default have a much higher debt loans relative to their income. Simply put, someone who owes compared to what they make is more likely to default on their loans. I know that this may clearly sound obvious, but it's not something that you can assume without having the necessary data to back that up. And now that we've backed that up, we have actual evidence. This insight matters a lot in the real world. For people working in banking, like financial risk analysis or lending officers, this kind of data helps them spot risk early, long before a loan is approved. It can mean the difference between making a smart lending decision or taking on unnecessary risk. And there you have it. From basically setting up the data to drawing meaningful conclusions and getting a better understanding of the SPSS interface, we have gone through everything. So I appreciate you for sticking along with me, making it this far. And if you found this video useful, please feel free to like, subscribe, leave a comment. And thank you so much for taking the time.